Hello friends, in the previous section we have solved some organic questions which asked in 2023 GSI. Now we will discuss some organic questions from 2023 GSI. This is second part. The first question is epoxidation of this trans-Tuscalin derivative in presence of MCBPA. Question number is 105. So here I am writing the structure of the given trans-Tuscalin. Here methyl is above, hydrogen is below, so I have kept the methyl above and hydrogen below. Okay, now epoxidation has to be occur. If epoxide approach from above side top face, we will have the steric hindrance with these methyl groups. Okay, if epoxide approach from bottom face, we will have less sterics because only hydrogen is there. Okay, so the epoxide approaches from the bottom face of this given alkene. So this is the structure of given MCPPA, metachlorobenzoic acid. So first this lone pair attack takes place here, then this pi bond migrate to the oxygens and give the corresponding intermediate. Okay, this intermediate undergo deprotonation with that metachlorobenzoate base. Okay, now we will write the another form of this given epoxide. We have methyl already above, so I am keeping above, and hydrogen below, so I am keeping below, and this epoxide also down face to the hydrogens only, so I am keeping below. So the correct answer is B. The next question is the major product formed in the following reaction. Okay, this is simply Sharpless epoxidation reactions. Here we have to follow few points that I will tell now. The first point is we have to give number to the given alkene. Second point is draw the arrow from 1 to 3. If the arrow goes clockwise direction, the plus diethyl tartrate allows the oxygen addition from the top face. Minus diethyl tartrate favors the oxygen addition from the bottom face. If the arrow is anti-clockwise, the plus diethyl tartrate allows bottom face addition of oxygen. If they have given minus diethyl tartarate, the oxygen addition occurs from the top phase. Okay, these are the key points, we have to keep it in mind. So now I am giving numbering according to the atomic number priority. This carbon is attached with the oxygen of the given allyl alcohol, so I am giving 1 here. This one is second, this one is 3. So I am giving arrow from 1 to 3 anti-clockwise. Okay, so 1 to 3, and they are given plus diethyl tartarate. Anti-clockwise means plus diethyl tartarate gives bottom base addition. Okay, so the epoxide oxygen will be below. So this is the correct answer. Here top phase addition, bottom phase addition only, but the position of alcohol is changed, so A is not the correct answer. Now we will discuss the second question. They have given diethyl malonate. If we treat this diethyl malonate in presence of base, the proton will be removed from here, which is highly acidic protons, because it is attached in between the two carbonyl groups. The next starting material is Michael acceptor. So this is alpha, this is beta carbon. So this is more electrophilic carbons. So the Michael acceptor will do 1,4 addition. In presence of ethanol, this negative charge will take the proton, because ethanol they have used as a solvent here, and we will get the corresponding neutral molecule. Here what happens, we have again this ethoxide base, which will remove these alpha hydrogens and will give the corresponding anion. This alpha hydrogen also is acidic alpha hydrogen. This carbon is electrophilic carbon, so this anion will attack here, and this ethoxide will be removed from this molecule, and we will have the 6-membered ring as product. Okay. In presence of acid under thermal condition, what will happen? Ester hydrolysis will take place. I am not writing the mechanism deeply. So we will have the corresponding acid product. Under thermal condition, decarboxylation will take place from this molecule. Then finally we will have our product. So D is the correct answer. Now we will see the next questions. They have given one alkene here and two reaction condition they have given. Under these two reaction condition, what is X, what is Y? First we will find out which is Y. This alkene in presence of mercury acetate will undergo oxymercuration reaction. Okay. Now we have water as a nucleophile, because you can see this, they have used water. This water will act as a nucleophile. So it will attack this carbon and we will have the corresponding product. Okay. Now OAC minus will take one proton from here and we will have the neutral molecule. Now what will happen in presence of sodium borohydride? Reduction will happen. Okay, so the hydrogen and hydride ion released from the sodium borohydride will reduce this mercury attached carbon and we will have the corresponding product. So this is Y. Now we have to find out which is X. This alkene will undergo protonation in presence of this acid. This will take this proton and we will have the corresponding carbocation. Okay, now we have a possibility to change the carbocation into the stable carbocation. This is secondary carbocation. We have hydrogen here, alpha hydrogens. This 1,2 migration will take place to give the corresponding benzylic carbocation, which is more stable than this secondary carbocation. This intermediate will react further with this water and we will have this product as X. So the correct answer is C. In this question, they have given one pinene molecule. Okay. In presence of bromine in H2O, we will have the bromohydrin product, which forms via brominium ion formation. Okay. When we treat this alkene with the bromine molecule, at first we will have the brominium ion as a intermediate. Okay. This molecule will undergo nucleophilic attack with water. Okay. Now the water will attack which side? From here or from here? In general, the water nucleophile will attack from the more substituted carbon only. That time this CBr bond will break and we will have the corresponding intermediate. Okay. So this water attack will take place to the opposite side of the brominium ion, which means this bromine and this OH will be opposite to each other. Okay. After loss of one proton, we will have this molecule. I have placed the bromine and OH opposite each other because water nucleophile will attack opposite to the brominium ion. Okay. When we treat this molecule in presence of sulfuric acid, protonation will occur to the hydroxy group. And water will be removed in the next step from this intermediate, and we will have the corresponding carbocation, tertiary carbocation. Okay. Now we will have the byproduct from the sulfuric acid after protonation as such as O4 minus. Okay. Now this will take the proton from here or from here. Which side this HSO4 will take the proton. Okay. So if proton takes place occurs from this side, we will have the more substituted alkene as side subproduct. If proton occurs there happens from this methyl group, we will have less substituted alkane as the product. This is Hoffman product. This reaction takes place via E1 elimination. Okay, we know formation of more substituted alkene is favorable than the less substituted alkene formation. So this is the product for the given reaction. So we have only one option, that is here. So option C is correct. Which one of the following is the correct sequence for the synthesis of 1-bromo 3-trichloromethylbenzene? So I am writing the structure of this given compound. This is the compound they asked here. Okay. In option A, they have given if we treat with the toluene in presence of bromine with iron, we will have major product as para-bromo-toluene. If we treat this molecule with chlorine in presence of light, we will have this one as the product, but the asked product is metabromo 3-trichlorobenzene. Okay, so for the synthesis of this compound, option A is not correct. Next we will see B. Reaction of chlorine with the iron metal, then treating with the bromine in presence of light or heat. Okay, if we treat this toluene in presence of chlorine and iron, we will have the corresponding para chloro product. But in the given molecule we have bromo, but here para, as well as this is 1/4 position. Okay, so option B also incorrect. In the next option, reaction of toluene with chlorine in presence of light or thermal condition, then treating with bromine. If we treat this toluene with the chlorine molecule in presence of light or thermal, we will have the corresponding product here. Okay, if we treat this molecule further with the bromine in presence of iron, we will have the metabromo as the product, because CCl3 is a electron withdrawing group that will do meta direction. Okay, electron withdrawing groups are meta directing group, electron donating groups are ortho and para directing groups. So in presence of bromine and iron, this CCl3 benzene molecule will give the corresponding meta product. So option C is the correct answer. In this question, they have asked one Friedel-Crafts alkylation reaction. If we treat the benzene with propyl chloride in presence of aluminum chloride, what will happen? At first, this lone pair present on the iodine will attack this Lewis acid, and we will have this type of adduct. Okay, then this CCl bond will cleavage, then we will have the corresponding carbocation. Okay, this carbocation will react with the benzene here, and we will have the corresponding product. Okay, then this hydrogen will be removed from this molecule to gain the aromaticity of this benzene ring, and we will have this molecule. But the problem is, this carbocation is primary carbocation. Here there is a chance to get the secondary carbocation by 1,2 hydrogen migration. This will migrate here, and we will have the corresponding secondary carbocation, which is more stable than the primary carbocation. This carbocation will react with this benzene, and we will have the corresponding propylated molecule. This is the major product, and this one is minor product. They have given major and minor. We have major here, so option B is the correct answer. In this question, they have asked which one of the following substrates undergo bromination reaction on aromatic ring at fastest rate. Now we will arrange the rate of bromination for the given molecule of A, B, C, D. Okay, the rate of reaction is depends on how much A aromatic ring activated and how much the A aromatic ring deactivated. If the aromatic ring activated, the rate of bromination will be more. If it is deactivated, rate of bromination will be less. So C option D, this benzene ring attached with one electron withdrawing group of amide, which will deactivate the benzene ring by pulling the electron. So this will have the least reactivity. The second reactive molecule is option A is the second, because C option A only CH2 carbon are there. In option C, the CH2 carbon, one CH2 carbon attached with electron withdrawing group of nitrogen, so activity to the benzene ring will be lesser than A. So lesser than A. So I have placed the C here. So the third one is option A, the fourth one is option B. Okay, this is the rate of reactivity for the bromination of the given molecules. Okay, the B is highly activated because the nitrogen is directly attached with this benzene molecule, and this lone pair will be delocalized with this aromatic ring. Okay, so the electron density around the benzene will be more, so that nucleophilicity is more, so reactivity is more than A, C, D. So option B is correct. Now we will see the next question. Here they have taken the toluene reacted with one alkene in presence of acid followed by oxidation with the KMNO4 reaction. So we have to find which is the product. At first, what happens, this alkene undergo protonation with this proton or acid. We will have the tertiary carbocation. So this will form major, then primary carbocation. Okay, because tertiary is more stable than primary. This tertiary carbocation reacting with the toluene to give the corresponding intermediate. Okay, so para isomer will form major, then the ortho isomer, this methyl group ortho directing group as well as para directing group. If reaction goes ortho, we will have the steric hindrance between this tertiary butyl group and this methyl group, so para product will form major, then the ortho one. Okay, now the molecule is not stable, so deprotonation will occur here to gain the aromaticity. We will have this product. So in presence of KMNO4, what will happen? This aromatic methyl group will undergo oxidation and it will give the corresponding acid. So option B is the correct answer. In the next question, they asked which one of the following compound will not be formed in the given reaction. This reaction goes via benzene mechanism because we have chlorobenzene and they have given strong base of sodium amide, and the reaction has been done in liquid ammonia. Okay, so we will have the benzene formation as intermediate. Okay, and this carbon is labeled carbon. Okay, we have two hydrogens, so we have two possibility to remove the proton and form the corresponding benzene intermediates. Okay, so first elimination of chlorine will take place, and we will have the corresponding benzene. Okay, if base remove proton from here, and we will have another benzene. Okay, the labeled carbon is here. Now addition of nucleophile will take place. It can attack here, and we will have this one as product. When this intermediate react with ammonia, we will have the corresponding product, aniline product. If NH2 attack here, we will have this isomer. When it reacts with the ammonia molecule, we will have this one as product. If this intermediate react here, we will have this isomer in presence of ammonia. We will have the corresponding aniline. When this nucleophile attack here, we will have this isomer in presence of ammonia. We will have this aniline. So totally we are getting 4 anilines. Okay, now we have to compare this aniline with option A, B, C, D. Okay, so among A, B, C, D, one is not the product. Now we will check this compound 1, 2, 3 and 4. Okay, 2 and 4 are same only. Okay, so this is para product is here, option C is there, 2 and 4 is option C, and you see 3 in the option, check where C is there, meta product. Option A is here, option A is the 3 meta product, and you see where 1 is placed among B and D. So 1 is here, in option B. So this molecule is not found. Option D is not found. So the correct answer is D. We have to synthesize this 4-nitrobenzoic acid from benzene. Okay, they have given 4 synthetic method as option A, B, C, D. We have to find which is feasible method to synthesize this corresponding acid. Okay, so first we will take option A. When we treat the option benzene molecule with methylene chloride, methyl chloride in presence of aluminum chloride, it will undergo Friedel-Crafts alkylation reaction and we will have the toluene. If we oxidize the toluene with the KMnO4, we will have the corresponding benzoic acid. This benzoic acid, this CO2H is electron withdrawing group and act as a meta-directing group. Okay, so when we do nitration with the nitric acids with the sulfuric acid, we will have the meta product only, but we need para product. Okay, this is para product, this is meta product. So option A is not correct for the synthesis of this acid. Now we will go through option B. First nitration reaction in presence of HNO3 and H2SO4, we will have the corresponding nitro compound. Okay, when we treat, actually this benzene ring is deactivated by this NO2, so electron density is less because NO2 is electron withdrawing group. So with this deactivated benzene molecule, if we do Friedel-Crafts alkylation, that reaction won't occur because alkylation won't go, so that we can't do the oxidation reaction also, because this is the limitation of Friedel-Crafts alkylation also. We can't do the alkylation with the deactivated molecule. So option B also not the answer. Option C. So if we do Friedel-Crafts alkylation with the benzene, in presence of aluminum chloride, we will have the corresponding toluene molecule. This methyl group is moderately electron donating group, so it acts as a ortho and para directing group. Okay, now if we do nitration in presence of HNO3 and H2SO4, we will have the corresponding para nitro compound. It will undergo oxidation with KMnO4 and we will have the corresponding product. So we got the para-nitrobenzoic acid and they asked para-nitrobenzoic acid only. So option C is the correct answer. Option D, they have given at first nitration take place followed by carbonylation with the CO and sulfur HCl aluminum chloride. This reaction is not feasible for doing this synthesis of 4-nitrobenzoic acid reaction. Hence option C is the correct answer. We will discuss about the phenol-phenolane reaction. So they have taken 1,2-diol and treating with the in presence of acid, we will get the phenol-phenolane as well as crossover product, because two molecules reacting together in presence of acid to give the corresponding crossover product as well as phenol-phenolane product. Okay, So first we will write the phenol-phenol product, then we will write the crossover product. When we treat this diol in presence of acid, we will have the protonated intermediate. Okay, from this water molecule will be removed and we will have the corresponding carbocation. Carbocation will form here only, not here. Two methyl group attached to carbon won't form the carbocation due to the stability reason. Here also tertiary carbocation only, the phenyl substituted carbon also will form tertiary carbocation due to the extended delocalization. This carbocation will form major. Okay. Now 1,2 migration will take place if oxygen hydrogen bond shift here. We will have the methyl shift product. This is the phenol-phenol product. So when we treat this another molecule with acid, we will have the protonated form here. Okay, this one will give the corresponding carbocation. Followed by 1,2 migration with ethyl group, and we will have the corresponding product. Okay, now we have to find the crossover product. To find the crossover product, just take the carbocation from both the molecules. Okay, so one carbocation is here, the another carbocation is here, so I am writing both are here. Now what will happen? The intermolecular migration will take place between these two carbocation when OH bond cleaves. When OH bond cleave like this ethyl group will be migrated here. When this OH bond cleavage happens, this methyl group will be migrated to this carbocation. Now we will have this product ketone. This is crossover product, and another product is this also crossover product. Now we have found which is crossover product, which is phenol-phenol product. Okay, now we will read the statement. Now we have to find where is 1, 2, 3 that they have given here. Okay, 3 is here, 1 is here, 2 is here, and 4 is here. 2 and 4 is crossover product. Okay. Now we will read the statement. 1 and 3 are crossover product and are formed by intermolecular reaction. We have found 2 and 3 only crossover product here. So option A is not the answer. 2 and 4 is the crossover product and are formed by intermolecular reaction. So option B is the correct. In option C, 2 and 4 are called crossover product and formed by intramolecular. Crossover product won't form by the intramolecular product. Apart from that, 2 and C is not correct. B only is the correct answer. That is intermolecular migration. This is intramolecular. So C is not correct. 1 and 3 are called crossover product and they are formed by intramolecular. And 1 and 3 is not the crossover product also. So option D also wrong. Hence, option B is the correct answer. Now we will find the product for the question 118. Okay. So the nitrobenzene is deactivated benzene. Okay, deactivated benzene always won't undergo Friedel-Crafts alkylation reaction. Only activated ring will undergo Friedel-Crafts alkylation reaction. So we won't get the Friedel-Crafts product. This is the limitation present in the Friedel-Crafts alkylation reaction. So what will happen? This propyl bromide will react with aluminum bromide and it will form the corresponding Lewis acid product. Then this CBr bond will cleave and we will have the primary carbocation. Okay, this primary carbocation will undergo 1,2 shift, 1,2 migration to give the corresponding secondary carbocation. This is not stable, so it reacts with aluminum bromide to give the corresponding 2-bromo propane. So option C is the answer. NO2 is a deactivated product, so no alkylation. And D also will not form because we are having carbocation. Carbocation can react with another carbocation. Okay, carbocation can react with the negatively charged species, so that we are getting the bromide, 2-bromo propane molecule. The major question number 115, the major product A and B formed in the following reactions they are asking. In presence of acetic acid, protonation first takes place. To the OTS group, okay, which is good nucleophile. After protonation, the acetate ion attack opposite to the leaving group, SN2 reaction. So we will have the inversion product. when we treat this is compound with the acetic acid, what will happen? Protonation at first will take place. Okay. Now what happened? This OAC acts as a neighboring group. So I am writing the structure like this. Okay. Or we can write like this also. No need to do confirmation. Draw the conformational structure. So this attack, this carbonyl lone pair attack will take place to the opposite direction of the leaving group, SN2. Okay, now where the nucleophile will attack? The acetate nucleophile these bonds both will be in the syn direction only, because you can see the OS is opposite to the leaving group and nucleophile will attack the opposite to the leaving group, so we have the syn directions, which means this bond only. When nucleophile attack opposite to the leaving group, again one SN2 is occurs. So we will have the corresponding trans product. So this also trans, this also trans. So option D is the correct answer. When SN2 happens 2 times, we will have the retention configuration. When SN2 happens 1 time, we will have the inversion configuration. In the first reaction, only 1 time SN2 occurred. In the second reaction, here one SN2 reaction. This carbonyl lone pair attack backside of the OTS. And again OAC attack opposite to the leaving group. So we have the retention configuration. So option D is the correct answer. Now we will discuss question number 120. Consider the following solvolysis reactions. The extent of neighboring group participation of phenyl group follows which one of the following order? They are asking rate of the reaction only simply. So neighboring group participation is favored when we have the electron donating group in the molecule, as we just discussed in the question number 119. So they have given methoxy, which is electron donating group. Paramethyl is also moderately electron donating group. And another chlorine is there. This chlorine will show act as a electron withdrawing group. It will show minus I effect. Okay, this methyl and methoxy will show plus I effect, inductive effect. This will show minus inductive effect. Okay, so reactivity for the SN1 solvolysis reaction will be slower to the chlorine attached molecule. So I am writing the order. Paramethoxy will have higher rate due to the electron donating group. present in the molecule. Second, the paramethyl will have the lower than the paramethoxy. Third, I am putting hydrogen. Fourth, I am putting chlorine. So the correct answer is D.